Those are Saudi soldiers, by the way. On those ones.
Those will probably stop some big ass shrapnel at least.
Yeah, but if you take to a pole and you have a pole
Bullets,
enclosed with,
grenades, maybe, yeah.
with a dipole field, then it makes a lot more sense if you have those numbers paired by 2 with separation. If you look at a field and you look at our world, we're having an 80-degree from our sun basically in both hemispheres. And one pole, that means you should have another duality pole on the other side of that one separating in between the 2.
Dipole.
Yeah, but if you take that to a base 12 circle, then you get an extended pi. So, and if you look at our star signs being 12 signs, it would make more sense to use base 12 on the ground to connect the sky with.
I learned about the dielectric stuff, how they're insulators. Insulator materials. Yeah.
Yeah, if you look at hydroponic, basically is working as an exclusion zone where you get a separation of charge and discharge. And if you have hydrophobic, that is basically the resistance of the charge, but still storing that charge. And if you look at what they do with I don't know with condensator, I believe it is called in English, that is a layering of hydrophobic materials that generate that charge in between the dielectric. And that is the buildup of charge, and it's just layering of charge on top of that. And it's building up until it discharges. That's all it is.
Hydrophobic materials. What would be hydrophobic materials? I know there's a hydrophobic spray I've seen, but I've never heard of hydrophobic material. Plastic is hydrophobic, no?
Should be like,
yeah, plastic is hydrophobic, for example.
Yeah, okay. Rubber.
Rubber, yeah. Wait, does that mean if something is dielectric, then that means it's hydrophobic?
In a lot of cases.
Ooh, look at that!
It might be true in all cases. You may
slowly
check that.
I gotta look. I gotta look now because look at that.
Yeah, ChatGPT the shit out of that.
Yeah, look
I
at
don't
the
know. People have a
exclusion
problem with
zone,
me
because
looking up
that is the
information.
thing they are abusing to generate an flow in the sky of non-resistance.
I'll teach you about the little bit of stuff I know if you ask. So, just ask.
Yeah, but if you look at water, if you buy electrolytes, you can make hydrogen gas. If you know, throttle blows in the gas into an engine, basically. You could replace that by that hydrogen. So if you look at what they are really taking with them as fuel, and you they're showing you that you can cook on a hydrogen stove and you can get the water vapor out of the sky to get that charge out of that and that water out of the air to use it directly. If you apply all that on a jet engine, you get a full system. Requires much input from the outside.
Any of y'all mess with muriatic acid?
Negative. Can I read you something here in a sec? You can go ahead and make your point. I just wanted to see if I can read you something.
Just ask.
Well, this is an interesting concept because you're kind of you're getting ahead of the game a little bit on dielectric. This might help give you a little foundation. So, like, the word electric is actually a Greek-derived word meaning amber. Amber is a translucent, semi-transparent, yellowish mineral, which in the natural form is composed of fossilized resin. The ancient Greeks used the words electric force in referring the mysterious forces of attraction and repulsion exhibited by amber when it was rubbed with a cloth. They did not They did not understand the fundamental nature of this force. They could not answer the seemingly simple question, what is electricity? This question is still unanswered. Though electricity might be defined as that force which moves electrons, this would be the same as defining an engine as that force which moves an automobile. The effect has been described, not the force.
I wonder why they called it. Amber is just like tree sap, basically, that falls and dries.
Yeah, I'm guessing it's like
If you
static
look at-
electricity that they produce when they rub it.
Yeah, I could
But if
see
you look
that
at
kind of
Tesla's
like a
count,
plastic rod. They usually do that with a plastic tube when people are doing the whole static
but
electricity.
that rubbing is just on one field. But what Tesla did, it was combining two fields that are rotating, but making them rotate towards each other so they come together at the center. And that is when the negative charge that is created top of those fields just by movement alone, when that gets under pressure together, that is when you get a positive charge in front of that field. So that is basically what we call electricity.
What's getting pushed by those two fields, you mean?
Man, I feel like it gets more complicated the more I keep looking for electricity, man. I hate it, man.
That's
Why'd you bring
exactly it.
up,
Well, I wanted to
why'd you
say
bring up-
that. Oh, good.
I was going to ask, why do you bring up muriatic acid? And that's just something they use to clean concrete shit. It'll burn some shit up though.
Yeah, I was gonna say if you want to play around with it, you can make like little bombs. They're not bombs, you know what I mean? It's just like sound bombs.
Yeah, that's pressure building up. Yeah.
Yeah, if you got a cousin or something, well, I don't think you should show them your cousin. I don't know. I used to fuck with it when I was a kid.
All right, I didn't mean to interrupt you. Thanks. Go ahead. I'm sorry.
Very good. I'm glad you. I'm glad I found out what that was.
Go ahead, man.
Well, basically, muriatic acid is like if you ever have that what is it called? CNC. I don't know. It's like a concrete cleaner. CRC? No, not CRC. Whatever.
You can use it for ceramic tiles too to get rid of rust and stuff like that.
It removes really hard water stains and shit. There's a product that's basically muriatic acid. There's a name for it. Forget the hell.
Highly corrosive. It burns your skin. And don't breathe it in. But if you get a water bottle, like a Coca-Cola bottle, right? And you get you make a little shit ton of aluminum balls, like really small aluminum balls, like Skittles. You make I don't know, 30 of those and just throw it inside the big 2-liter water bottle. And you fill that up with muriatic acid, I want to say 1/5 of the bottle. You fill it up and you shake it up, close the bottle, shake it up, and throw it and just run for it, bro. That shit is gonna boom. It's fun.
That's dope.
Just make sure you don't get any of the acid on you. But
just to give you some clarity, Tri-Edge, inside the topic of electricity, we know about the same as the Greeks do about the nature itself. Not much has changed about the understanding of the nature of electricity, but we've just figured out how to harness and use it. And I feel like that can go a long way in because a lot of times trying to understand an aspect of electricity, a lot of the conversations around electricity may get really deep in here.
I hate it, dude. When I had to do radar stuff, I hated that part. That lectures, bro. Those lectures are horrible.
Yeah, so it's just a good weapon to have that no one actually understands electricity itself. So it's we can put it on a racetrack and harness it a little bit. So it's interesting. If you've ever heard, I was talking about the orbit theory, which is the idea that electrons orbit and a boundary around a nucleus, and that's what creates basically matter around us, atoms. Yeah, that's the terminology they use. Which this is the mainstream. So I'm kind of positioning with that just to explain, so you'd have molecules that make up compound or combined molecules make compounds, and you can break those down into atoms even smaller. And the atom itself is electrons, protons, and neutrons. But this is presenting the idea that the electrons are what define this boundary surrounding the nucleus, or basically the shell of what they call an atom. And there's a lot of debate about whether or not these electrons are even real, because the measurement techniques they use are not real. They're inference techniques, so they're really measuring vibration and resonant points in a field. So we know electrons are reappearing and disappearing all the time, 99.9% of the time, actually. So, and these points that they reappear and disappear on happen to dictate, what type of atom that it's part of. This is why the periodic table is linked to the electron orbital theory. And it's possible to totally throw this out the window. It's possible that orbital theory is totally wrong, based on electrons actually are resonant points rather than being physical objects you could measure. So this is really more of an idealistic model. But I don't know if that was a good breakdown.
Are you talking about the clouds, the orbiting clouds that the electrons go to?
Well, inside an atom, the structuring of an atom, you have the electron boundary outside the shell.
Mm-hmm. And so you have different you have different clouds, essentially, different fields, different levels. Is that what you're talking about?
Yeah, you could use the term cloud. Yeah, depending, I've got helium has one shell,
one electron.
Yeah. So then you've got lithium 2, oxygen 2 with the shell.
Well, so what you're talking about? So what you're talking about is called valent electrons. In the outer shells, and they'll attach to other valent electrons and make different chemicals depending on the makeup of the outer shells of the electrons that are there. So it's on the outer shell of most on the inner shell, there likes to be 2 electrons there to be stable. So that's why you have helium being highly reactive, and then hydrogen being highly reactive, and helium being a noble gas. It already had its 2 electrons in that cloud.
Noble gas.
Yeah, and it's good thing to bring up, because it gives us kind of a traction on engaging on electrons and how they are part of what would you say, matter, or part of.
I mean, they are. They are matter.
Doesn't matter all
small.
The chemicals altogether.
They're just really small, but I think what you're talking about, it's the orbit clouds, and then you have those valent electrons. Some shells want 4 electrons out there, some shells want 6. It just depends on the chemical. I mean, the element.
Yep. So, and it's interesting. Electrons are, this thing we can harness and kind of send on a track and use it as energy somehow. It's so wild. Is it actually electrons? I guess the term electron for whatever they're measuring can be as accurate as we want to let it be, because it just gives us this. It's a language to explain, really, an inference model.
Yeah, what you could say is it determines the spacing in between the different gradients of charge. Because if you look at what they, when that neutron turns into a proton, it becomes part of the whole, but that has to do with the density, with the amount of pressure that is built up in that space itself, I believe.
It's interesting. Like if you look at how a capacitor works, like you almost have like, it's a lot of times people try to explain it as like a rubber band effect or like a buildup of pressure. Like the idea that I can have two plates that are not touching, and I can push electrons into one of the plates, and it's going to create a magnetic field that's going to interact with the plate next to it and excite the electrons in that plate or displace them. And if I connect that plate to a battery or another current or a circuit, I'm going to get an output. Right, I'm going to get that rubber band to kind of unsnap. Right, this is kind of the capacitor effect. It's like pop. If you've ever seen somebody hit a capacitor with a piece of metal or something.
When you hold that rubber band in rest close to your lip, when you stretch it, you feel the heat coming off of that rubber band, basically. That is the energy from expanding that thing. And in a way, it is showing the build-up and release of charge, compression and expansion. And even if you look at what measured with P waves and S waves in our ground, that are oscillations, and that is an expansion and a compression, basically.
Yeah, there's sine, cosine waves, positive, negative, even inside like this center boundary, and this negative, what they claim would be the dielectric center. There's still positive, negative charge gradient inside that. So it's the idea, and talking about just chemical reactions creating bonds. Like these have extremely important like electromagnetic interactions that happen that I think would probably be more, it's like easier to explain a chemical reaction with, like, I've heard terms like what's it called, like a dipole, quantum dipole or something like that.
Yeah, but if you look at the positive and the negative, it isn't. Everybody always sees that two separate things, but basically they are one, because they are. It's a unification, because electricity is a hybrid, basically, of the positive and the negative. That's what they tell us. But if you really look at it, if you look at elements all building up that negative charge just from interacting with each other, just by the movement itself, and when it gets under pressure, that is particle or wave. I'm telling you, it's neither. It's the induction rate in between elements, which we perceive as light. And if you look at water with the phase, the separation of charge and discharge, we even see that on the shorelines with our oceans, where the separation of the charge and the discharge takes place. Why is that? The Earth itself is negatively charged, while everything that is on the move, like the sky and the oceans, they are positively charged. So in a way, the oceans are the big batteries of our world.
And this charge gradient, large scale, seems to be creating a lot of different, like, I guess, like magnetic domains.
Yeah, but you need two fields for that. And NASA measured the electron Earth magnetic field in 1962. And even back then, they already told us that two fields within a bigger field. And if you look at Tesla's rotating magnetic fields, and how when you have counter rotation like that, we see that even happen with our tectonic plates, that where the Americas have a slight rotation anti-clockwise of a few centimeters a year, and Eurasian does the same for a few centimeters a year, but clockwise. That's an electric circuit on the ground you're looking at. And even the jet stream moving over our world just from one direction on all hemispheres, that shows you that and they know that there is a non-dipolar field in that two field, electromagnetic field. So, and if you look at the vertical and horizontal, that is exactly what they are showing us with electron. And if you see how that is flipping around, that is exactly a little bit like we also see our sun move through our sky. So in a way, they are trying to show us what our world is, but I think nobody really knows.
Can someone help explain to Left Lane what the topic is?
We're talking about, I think we're kind of just trying to explain and talk about the idea of like how charge interacts with reality more than like some of the mainstream model claims, like a chemical reaction. I think that it's kind of gotten into some deep like perspective, I guess, individual perspective. Left Lane, if you had a take on how about how field works, or we started with electrons and orbital field boundary.
Are you talking about electron probability shells?
Yeah, that's actually a really great way to say it. I was going to respond to Krizzel and say, like, I think it's like these are resonant points. Like they seem to be a result of a different source. You know, if you look at toroidal math, like Mark Roden has broken this down a little bit. But like 9 mathematically reflects this, like the dielectric center, the cone in the middle of an electromagnetic field in a toroidal shape. You know, that center part, that's the electron boundary. You know, electrons are not passing past this boundary. So the strength of the dielectric field is a reflection of the strength of the magnetic field. So it almost makes more sense if there's, you know, if the structure of the 3 and the 6, the positive negative dipoles, are more reliant on the dielectric. You know, why haven't they really deep dive the idea of how to, like, would you say, like, artificially, or I don't know what idea you could use to create a dielectric boundary, because just creating a dielectric boundary would in turn create a magnetic field.
Yeah, but if you look at equator with a 90-degree barrier over your head, that is the highest point in our world. That is 9, basically. And if you look at Antarctica, that sun rising like 60 degrees in the sky, that is your 6. So we're missing the 3.
Well, 3 and 6 are infinitely linked. Just with I think you probably know about this, but you take 3 and 3, you double it, you get 6. So you go to 6, and then you try it with 6. 6 plus 6 is 12. 1 and 2. So in the number 12, that you have the number 1 and 2. You add those together. 2 plus 1 is 3. It goes right back to 3. And then and you do this with all the other numbers. I think it's 1, 2, 5, 4. Or sorry, 1, 2, 4, 5, 7, 8. That all are in the infinity symbol. So these would be like the space that wraps around. It's like the toroid, right? Like the infinity symbol that's overlapping the toroid, and the 9 represents your center dielectric. So the 3 and the 6 would be the positive negative poles, or the field boundaries, like this kind of 3D infinity symbol. But this would be a dipole. Or sorry, yeah.
Yeah, but we got multiple magnetic anomalies in our world. We got that triangle, and then you get that shifting pole from Russia. So that's 4 points extra.
Well, you can have different like magnetic field interactions and stuff, but just like a normal one centrifugal dielectric field boundary, you could also make the dielectric field just circular, like not like a hollow donut where you have that cone shape that's elongated. You can make a very tight circular dielectric field, which is apparently what the Nazis were working on with Project Hannibal. They created a sphere with a spiral mold inside of it, and they put a liquid mercury in there that rotates with a charge. So a positive negative charge makes it rotate clockwise or counterclockwise. And under high pressure, this would create a very, very, very strong dielectric field boundary. I'm sure it created a pretty strong electromagnetic field.
Yeah, but if you look at our world underground, then it looks more like you have a dielectric field within the toroidal field. Because when you have a toroidal field and you cut it in half and you put it with the openings on the ground, then you have like we have in our east hemisphere and a west hemisphere. And even if you look at if you have a top field, well, the land in the water gets injected to the outer field. You see input fields 1 cent station.
I didn't catch all that.
If you see it as one torus field, so a field cut in half and flipped on its side with the open circles on the ground as hemispheres, east and west, and connected it to the sky. But when you have another field that both fields that are in the field injected that outer field as one field, as one rotation.
Feel like Discord is screwing you over. I can hear you fine the last two responses, but I'm having trouble hearing you the whole time. It's like jumbly. Is that just me? Or
Which happens to me on X. It's ridiculous.
It's like the mic sensitivity's cutting in and out.
yeah, like right on the edge or something. When you were talking about inverting the fields, and when you connected your idea, like 3 of the words just like disappeared. So I couldn't hear what you connected.
Field. When you cut it in half, can you hear me now?
Yeah, can I hear you? Yeah, I heard you there. Man, I swear your mic's getting quieter and quieter. I'm going to turn you up a little bit though.
Turn my mic. To say, hear me now? Better?
Better. Yeah, I hear you. It's not better, but I heard you. I heard the word better. Yeah. It's like it's the same mic quality, but it's not cutting out. So.
Okay. No, if you have a toroidal field, when you cut that in half and you flip it with things down, around, then you have 2 hemispheres that are connected. When you look at NASA's research of 96 about being 2 inner fields with a big top field over it, when you place another field over that, then you would have a projection of lower fields on that top field.
I mean, it kind of sounds like you're explaining the field boundaries, yeah. And that's how they were laid out.
Yeah, but because you have that vertical and that horizontal field, I think that is.
It's kind of it jumbled.
Oh, because if you look at the magnetic field of Earth having a vertical plane, and when you look at how the stars have a clockwise, anti-clockwise in different corners, and even the sun does that, that might have to do with the magnetic field having that plane.
Do you think the sun is creating its own strong magnetic field that's overlapping with Earth's? Because I find that to be
No.
like measurable.
If I look at the sun, I think I have a star projection where you have that light coming from the center, but projecting everything that is in that is above that system onto the sky. Because if you look how that light is behaving, it's making it's from away from you and moving back in the direction of you, but farther away. So it's basically making an angle. That is showing you that it is a light reflecting to a system, but not the actual thing you're looking at. So I think the light really is coming from below the system, not above.
Well, I'm willing to believe it's a lot closer than they're saying it is and all sorts of things right now. Like I'm at a point where I pretty much believe that. It's just, I think it still has a very powerful magnetic field. I think it's some sort of plasma object, and it's, in another dimension, basically. It's not that it's far or close. I think it's in another dimension.
How about that?
Well,
Who was the guy that said that we had an artificial sun in Antarctica? That was funny. I'm still laughing at that, man.
Well, it happens all the time. You got a theory, and then you're like, oh, it's a crazy theory. But I mean, shit.
That was a little far fetched, and I'm telling the guy, like, dude, like you're taking this.
I mean, do you know about some of the classified tech they'd have?
Some stuff regarding like what my job is. Yes, I'm not gonna be able to tell you like other stuff that I'm not exposed to. The army,
Well, have you ever
manage
heard of,
clearances on need to know basis. That's how they manage clearance.
have you heard of Solar Warden?
The Solar Warden? No, what's that?
It is a supposedly top secret space program that's been going on for a long time, but like considering that could be not legit. Some of the weapons that they have available, like satellite redirected sunlight, it's not necessarily a weapon, but it's very doable and possible. Yeah, that's
like a satellite that shoots down sunlight.
Yeah.
Oh, you mean like the Hammer of Dawn from fucking Gears of War?
Oh yeah, that's a sick example. That's a sick. I played Gears 2, dude. I used to play Gears 1. So yeah, that idea of like this
reference, bro, because I thought I was waiting, man. I was like struggling here, bro. I was like, did I just fucking nerd the fuck out, dude?
That's a good ass game. I used to compete competitively in that game, actually. Shit, what were we talking about? Gears of War, dang it.
The sunlight making like that solar whatever warden.
Solar Warden.
Where they would use sunlight as a weapon for our satellites.
Yeah, so like the idea, and I'm it's totally a stretch to imagine they can make an artificial sun, but some of the tech they have, I think they could simulate one very, very easily.
They've done things like stuff like created a reactor that lasted like 24 hours or some shit like that. But the thing is, we're talking about if we're gonna be making artificial in the sense that it's man-made, right? But it completes all the functions of the sun. That means it has a nuclear fusion, right, inside the center of the sun that does not end. It does not stop, right?
Yeah, it's not happening. Yeah, you're right.
It permanently produces heat, energy, electric, magnetic, right? And then not only that, the biggest problem with the artificial sun is the amount of mass, the sheer amount of mass that you will have to find a way to compact into this tiny little sun on Earth. You're literally going to create a black hole.
Hey, Triage, I have a question for you.
Yeah.
You described the sun.
Describing the sun like on a superficial, simple way, yes.
So, can you describe it again?
So I was mentioning how the core would have like nuclear fission going on, which is what will be producing like the fire, the plasma, all that Joe, right? And then you would have the what was it that I mentioned earlier? Jeez. I feel like I'm waiting for the trap question here, bro. Geez, now you got me messed up thinking about, all right, what's he gonna hit me with, dude? I'm just waiting for it, bro.
Just
Guys, they
describe
can-
the sun.
I was gonna say,
Huh?
but before you answer his question, I was gonna say, like, I think they can project a sun into the sky with some of the tech they have. Like,
Not that bright, bro. You're not gonna tell me you're gonna freaking lighten up a whole continent. Like, there's no way.
Artificial sun is very real.
you can keep
Tech is
moving
there.
the goalposts to the idea that I got to recreate nuclear fission and the exact mass and the exact whatever, but like, they could
You got to measure the energy coming off of it, though.
they can simulate a sun-like light in the sky for sure. I think they could trick most people with it too.
Try
Not only
it.
that, but the
Look
problem
into
is, go ahead.
look into ionized gases.
So can I get back to asking Triage
Liquids and gases.
what he thought of the sun? Go ahead, like describe what you know of the sun.
All right, so basically, you got, like I told you, a whole bunch of stuff going on in the center, superheated gases, right? Getting to the point where it's doing nuclear fission in the center, which is like the main thing for you to create a sun, right? And then you would have to have an insane amount, an enormous amount of matter, of mass concentrated into like a sphere ish, so it can create a gravitational pull, so it can start simulating like electromagnetic fields, all that stuff, all that jazz. And then on top of that, you have to make sure that like it doesn't fucking implode into itself, or like it doesn't explode, or like it doesn't grow, or it's insane, man. It's
I would even
There's so much stuff.
You
like,
just described all that stuff, right?
artificial sun is not gonna work, man. Go ahead.
Well, so we're not talking. I'm not talking about making an artificial sun. I'm just questioning what you think the sun is. That's
you
all
were
I'm
asking
doing.
me what is it made out of, like literally.
Here we go.
Yeah.
Okay. I thought you were asking me to repeat what I said and on how an artificial sun could be made. My fault.
Artificial sun. I'm talking about what you think the sun is.
Yeah. Basically, the sun is a large amount of mass. That's a very understatement.
In a
Of hydrogen and helium.
mind you. In a vacuum. In a vacuum. Yeah.
I don't know.
That breaks the second law of thermodynamics.
Let's pretend it's in the vacuum, right? Let's pretend whatever.
No, it's not pretending, bro. You got space in a vacuum. That's what you think the sun is right now doing in a vacuum.
What is space then? Is it not a vacuum or close to a vacuum?
It is.
All right, so that's what I said. Why are you fighting me over it?
Well, I'm asking you, how does that happen, dude?
Like that in the vacuum? I don't know, bro. Like stuff just happens in the vacuum, bro.
God did it.
Stuff just happens in a vacuum, bro. Is that
just happens in the vacuum? You should ask God that question. How the fuck did He create stars in a vacuum?
But then why do you believe this shit then?
What are you talking about? Like what? Like how sun works and how it's made?
It sounds like Helios just doesn't think God can do anything.
Why do you believe it's a nuclear fission reactor in a zero in a vacuum?
Well, it's basically self-explanatory to a certain extent.
Self-explanatory? Who explained it?
Okay, look, if you think about it, right, you have the sun is composed of immense pressure, right? When you put mass in immense pressure, it creates a lot of heat. And since the sun is mainly made from like hydrogen and like some other stuff, right? It creates the nuclear fission, right, in the core, because there's so much pressure, so much heat going on, right? And since there's so much mass, it's not gonna burn out anytime soon, right? So it's releasing vast amount of energy, like it's insane amounts of energy.
But how come we don't ever see it get smaller?
Well, because like I said, the amount of mass that it has, you're not gonna see that happening in a human lifetime, man.
Why not? We haven't seen the sun decrease in size in all of known history.
It's like billions of years that suns last.
Like I said, we're not gonna see that in a human lifetime. It's impossible for us to see that. You can see it far away in the world with telescopes, stars dying stars. Once all the mass dries up, all the helium and all that dries up, and there's no more resource to burn, then it's gonna turn into a neutron star, and then that's gonna be even more dense, and that might create even a
big.
Huh?
It's not that big, dude.
Our sun's
it doesn't matter. It doesn't have to be really big
before it dies.
It's only 400 Earths, bro.
Just 400 Earths, right?
Just 400. We would have saw one Earth already dissipate by now, and we would have been able to measure that. And not only that,
I mean, where do you get those numbers? Where do you get those numbers?
We would have seen by now a shift in like either time or like, well, obviously time, but the cycles.
Hey, what is 400 Earth?
If you want to see a shift in time, you can just look at other stars. Not just
what is 400
ours
Earth?
is new. Go ahead, man. Sorry for interrupting.
What is 400 Earths?
Ask him. He's the one that said it.
They said the sun, but I think the sun's more than that.
I thought it was like you could fit 1,000 Earths inside the sun.
400, bro. Google it. You want me to Google it for you?
Okay.
You don't believe me or what?
No, I didn't. I didn't say you had to do anything for me. I just wanted the answer.
That's the answer.
400 Earths?
Do you think that even the mainstream model says the sun's going to get smaller as it ages?
Wait, I got a question now. I got a question because I Googled something and now this
Actually,
is crazy.
it's not 400. It's
1.3 million Earths.
Okay.
1.3 million Earth. Okay. Thank you.
Okay. So let's just say every year, right? Let's say with the amount of energy that the sun is dissipating,
it collects material until it has built up so much pressure.
Does it only?
It throws off its dust shield and it starts back over as just a little star build up back up until it becomes a big star again. That's what they tell us.
Wait, you said it collects material? How does it collect material?
That's
collects what like is it like a mailman?
Krizzel said.
Krizzel said the sun's like a mailman and it goes and collects mail. Mail collector.
No. They say that the space is filled with hydrogen and helium. So and then on the other side they tell us that it's vacuum space. So it's time they make up their mind.
Collect. So like, do you have hydrogen and helium like Jehovah's Witnesses that go and collect donations? How is the sun collecting anything? What is it? Ask nice.
I'm just telling you what they tell us what a sun nova means. That's what I'm telling you. Nothing more.
Oh well, I don't believe what they say.
So is it more?
If you look how everything grows from the inside out, their explanation is close to nature.
Close to nature. Oh yeah. Just add in the word nature and it solves everything.
Helios, could you give us, just because I'm interested actually, do you what's your perspective on what the sun is? Like what's its kind of, what's your definition or perspective on its nature?
It's a big circle in the sky that gives the earth heat and life.
So you don't have like any sort of secret sauce view on it. You just kind of are not sure about anything beyond what you can see.
I've never went and did any experiments on it. I couldn't tell you, but how did I determine that it's made of hydrogen and helium? I never determined that. Now, is it because of the color spectrum? It emits. I don't know. How come it ain't blue? What if it was made of methane? How come it wasn't made of methane? I don't know. They say a long time ago there was a lot of like collisions, and so who knows, man? I don't know.
Well, it seems to be the only thing holding stuff together out in this dark abyss is some sort of convergent, divergent field boundary. So I just suspect that the sun has its own, and it's some sort of reflection of what we call a celestial body. But I'm in the middle ground. I'm not a flat earther because I think it's a charge gradient. So we're dealing with a holographic 3D projection of consciousness. So anyway, I'll get out of that, but that's kind of the filter I see the sun as. It still has some of the same mechanics. The mainstream, they just refuse to.
You can go there if you want. We don't have to stop. That was kind of cool. But again, how would you determine that? Like, that would be more assuming and stuff, right?
Well, it's inference. So yeah. There's an inference process that I'm applying to get to a conclusion that I would be open to shifting gears on. I think being intellectually mobile right now about where we are and what we're seeing around us is pretty smart.
I think somebody was trying to talk.
Don?
No, it's passed. It was just kind of a tag there. But I mean, I guess the mainstream, a more accurate layman's description, there's so much hydrogen and such volume, stupid radio, that and so much temperature and so much pressure that the helium atoms or the hydrogen atoms are slamming into one another and becoming helium, the molecules fusing together, and that releases a bunch of energy, and all of it doing that is what we're seeing as the sun.
But we never see any like it's so it functions so well. It never just okay. Have you ever burnt your eggs, right? Or like burnt something on the stove? You applied too much heat, but for some reason the earth never gets scorched by the sun, right? So imagine the sun being like the fire underneath your stove, and the sun, I'd say, is pretty. It gives off the same amount of heat, I would say, depending on different things, and we can measure that change with if the earth is moving. I don't know. I've never seen it move, but and it doesn't feel like we're moving, but we can infer also that the earth is moving away. That's why we get temperature differential. Like when the earth supposedly like tilts. But how come the sun never scorches the earth?
I mean, we're at the perfect distance, man.
Yeah, but there's a deviation of like 3 million miles. So how come it just doesn't say oopsie, like how could it, like you didn't mean to, but you got a call from like your grandma and it's Christmas and you're cooking and you burnt the mashed potatoes or something. It's so easy, right?
Right. Yeah.
The earth never gets burnt from the sun, bro.
Well, I mean, again, like it's probably not the answer you want to hear, man. But we're at the perfect distance. Our orbit is literally letting us survive. How far we are from the sun. That's literally what is letting us survive. If you see Mercury, what does Mercury look like?
I don't know. I've never seen Mercury.
Oh, well, Mercury is basically a freaking planet that turned into just straight up hot. It's just straight up freaking lava
hot.
or like hot gas. I can't remember what it is exactly.
So it's like burnt like green beans. Crisp, burnt, char-broiled, right?
If you want to put it that way, I guess, yeah.
Well, a well-done steak.
Well, rock doesn't get burnt like that, though.
Yeah, but if you look at the sun, once it goes down, and if you look at the noble gases, how they react with oxygen, and it gives them a certain color, that is exactly what we see happening when our sun is down and coming up. It's just like it looks like it is gases interacting with oxygen and getting ignited.
Hold on, but somebody said that because Mercury is so close, it's burnt. Then we got another guy saying, hold on, rock doesn't burn. But last time I checked...
No, it doesn't turn black like you're describing.
But rock does. Especially that close, dude.
I don't think it's that hot. It's, what is it? Something like 700 degrees or something like that.
Well, thanks to Google, and you know,
Let's see what it says.
How hot is Mercury?
Freaking cooking.
800 degrees Fahrenheit, if you believe that.
Oh, yeah, you're fucking done cooked.
But how come it's only 800 degrees when we're 100 here?
Google, how hot is Mercury?
800 degrees.
That is a lot, my friend.
Oh, that's Mercury. Mercury is that hot. Now, how hot is Mars?
It should be hotter. It's only 39 million miles away. It should be way hotter.
Well, space is cold, bro. So the farther you get from the heat source, the colder the planet gets.
Venus ain't doing no better.
I mean, yeah, but like that's what I'm saying. It's still getting colder though. What is Venus?
Saying something is in space, therefore it should be cold, is also not true, right?
It's the absence of heat, man. If there's no stars heating anything up, it's gonna be cold. Space is like what?
If you're not near the
degrees.
extremely hot things in space, space is cold. I gotcha.
Space is negative 200 and something degrees. Almost
right,
zero.
But that doesn't mean that you can't have hot bodies, as you so rightly pointed out. We have stars.
Yes, and I said the farther you are from the star, the colder you're gonna get. It's like putting your hand on a fire in the woods.
I don't know why I even tried.
What are you trying to make sense of, man? That doesn't get better.
I already said it. I already said it. Yeah, it doesn't get better than that. Yeah.
If you try to put marshmallows freaking 8 feet away from the fire, bro, you're not gonna do nothing.
Yeah. What if the fire is very hot and pointed towards it?
Well, then you're probably gonna get something done if it's literally pointing towards it. But in the case of the sun, that's not the case.
What do you mean? The sun is always pointed at everything.
It's radiating everywhere energy. It doesn't point in one particular way. If it freaking points it at one particular thing, like the fucking 3, 4, 5 planets will be fucking burning crisp.
So how does it emit like in every direction possible? How does it do that?
Well, it's a burning ball of fire, bro. Plasma. Like, what do you mean? Like, you're gonna get heat everywhere.
Okay, so like
Pirates.
Hold on. So you got a thermocouple, right? Or let's just say you got a gas burner, right? And the way it expels or whatever heat from your stove.
How about we use a campfire, man? Right? Throw some wood in, some campfire. Throw someone in, turn it on fire.
But hold on, man. Just let me finish my question.
Don't do that.
Sure, go ahead then. Talk amongst yourselves, because I was going to.
I was just saying not to do. He just said throw someone on a fire and turn the fire on. I was just making sure if anyone was listening, they're not going to do that. Sorry, go ahead.
So imagine you had a thermocouple that could emit heat in a 3/6 or like a sphere, right? How would you achieve that? I mean, it's possible, right? You could make like a basketball type thing, and every millimeter or whatever, put a little hole where gas could come out, and it would emit like a sphere. But the sun doesn't have those like little paths for it to emit. It just emits outward, like, and pretty much evenly, right?
But why? Why do you think it emits like that? All uniformly, kind of.
Well,
What do you mean,
kind of like,
kinda?
yeah, kind of like if you take a steel ball bearing and heat it with a torch so it's glowing red, that heat is going in all directions from the ball bearing.
Bingo.
Yeah, but there was a problem when that sun is irradiating the Earth in its whole, and it should be penetrating it as a whole. And you have only on one side of that ball you have light. So it's impossible to have everywhere that radiation. But you say it's 93 million miles. That whole ball should be lighted up from all sides. So something is really off in your theory, no matter if that ball is spinning around or
lit
not.
on every. It is lit on all sides.
No, it ain't.
It is lit on every side.
Yeah,
What is happening right
but
now?
when the sun is hitting the ground, when there was clouds above, that sky above the ground will heat up harder and more than when that sun is hitting that ground directly without clouds. So that is meaning that big heat that you're proposing ain't coming from your sun above in the sky, but that was more heat coming out of the ground.
Where's the heat coming from?
Where do you think the heat is getting transferred from?
It seems like we only
everything
see
that
one side.
that's lived on the Earth decays, that generates heat on its own.
It seems like we only see one side of the sun, but like when we see an eclipse, how come we don't see the other side radiating, like not backwards, but the other direction? It's only
the sun rotates. The sun rotates, so we're seeing all sides of the sun over the course of about a month.
Yeah, but we don't see the other side.
Yeah, you can watch the sun rotate. You're seeing all sides of it.
Oh, what is a sunspot for 500?
It's a cool spot.
I'm not talking about the face you could actually see. I'm talking about the other side.
Well, when Venus and Mercury go to the far side, where they're in opposition, then we can see the reflection of the sun off of Mercury and Venus. So that's telling us that sunlight is going towards the far, away from the sun and away from us. Yeah, it's.
Or it could be our consciousness. Hold on. Or it could be our consciousness observing Venus and saying, well, there would be Venus there, but if I did apply my infinity eyes and my consciousness eyes, when I put them on Venus in the opposite direction where the sun should emit light to, I get to see it.
Yeah, I'm not sure what all that meant.
Well, I'm saying perhaps it's only because we look at them that we get to see Venus.
You think they disappear if we're not looking?
Yeah, that's what I'm saying. I'm saying it's just because we're looking at it. Imagine that.
Ow.
Well, due to Venus's inclination, we can see its entire orbit around the sun. And when it's on the opposite side of the sun, Venus shows up as a full disk. And when it's on the near side, between the Earth and Sun, that's when it turns dark because we're looking at the silhouetted side, and when it's at elongation, it's in half phase, just like the moon. So we can see that the Venus is being illuminated by the sun for its entire orbit, and we're seeing the sun rotate. Yeah, the sun is very, very much like what I described earlier. Take a steel ball bearing, heat it with a torch till it's bright red hot. It's radiating heat in all direction, which is just like the sun is radiating thermal energy and electromagnetic light in all directions.
Yeah, cool story, bro.
And this is why the Earth is in fact a globe.
Dun, dun, dun.
Yo, is that good, White? I haven't heard his voice in like a year.
Yo, what up, Fundy? Just chopping
Yo,
it
what's
up
up,
with
guys?
these Globers here.
As we do.
Dare say.